to this computer. Hello. What we're going to be doing in this video is, well, this is week 4, lecture 2, and we're going to be doing as many exercises from zyBooks as possible. So what we're going to do is we're going to open the exercises for week 4, which is going to be due next week, and we'll take a look. Um, I will say this is another reminder that when you're opening the exercises, you do need to navigate to zyBooks from both the week 4 reading and from the week 4 homework. Otherwise, your scores will not transfer to Canvas correctly. All right, here we are. I'm not going to do every exercise or anything because I want to make sure we get through them or through a lot of them, but we will do, some from most of the sections here. So section 4.1 here is about doubles, which you need to understand are just decimal numbers, right? So a lot of this stuff is stuff that we've already talked about last week. So things like this, right? Like declare a double variable named package weight and initialize the variable to 7.1. This should be easy by now. We just say double package weight. I usually copy paste because I'm lazy. Equals, and they say initialize it to 7.1, right? We need a semicolon on the end, and there you go, right? So declaring a double is easy. Giving it a value is easy. Okay. Which of the statement best declares and initializes a double variable? Well, if you look at them, the third one is bad because you don't want to leave off the decimal point when you declare a double because you can make mistakes with the math if you do. So just to show you, let me go to Eclipse here. This is left over from the previous lecture, so let me just delete everything in here. If I do double x equals, if I say, for example, what do I want? 5 over, no, like 15 over 9, like that, just a number. And I put, let's do it correctly first with a, oops, with 0.0, 0.0. So this is just 15 over 9, whatever that is. And I do system.out.print line x. And we'll take a look at what we get when we run this code. We get 1.66666. Okay. If you forget to put the zeros on the end, we get 1. Because without the zeros on the end, like the point zeros, then Java thinks that we want to be doing integer arithmetic, which means nothing after the decimal point. So even though we have a double on the left, which can store decimal points, the calculation on the right does not have anything to the right of the decimal point because Java assumed we wanted an integer. So this last one here is bad if you're declaring a double, although it works fine. The top one is bad because the percent sign is not going to be in there if you're initializing a double. You need to just type a number. Second one is the right way. Okay. Same thing on number 2. It's bad to put the -5 like this. It's good to put the -5.0 like this. Now, it says best because technically both of them would work, but the second one is better. Same thing on number 3. Technically, both of these work, but the second one is better. It's a bad idea to leave off the 0 there. Uh, Mostly just because it confuses people. All right. So just keep in mind what these things do. Integers are for things that you could count. Doubles are for things that require more precision in decimal numbers. So like if you were counting cars, that's an integer. If you're measuring the temperature, that's probably a double, right? Like you could have a half a degree. Person's height in centimeters, for any measurement, I would use a double. Even though you could say, 160 centimeters, 172 centimeters, whatever it is. But you could also have like 172.3 centimeters. So you would want to use a double. Number of hairs, That's something you can count. Average number of kids. If it's an average, it'll probably be like a decimal number, right? Because averages, you add up a bunch of things and then you divide by something. So, like it says here, nobody has 2.2 kids, but when you calculate an average, that's what you would calculate, maybe. Um, okay. So let's go down to the exercises that we actually have to do here. Looks like I did some of these before, but not for you guys. So let's pick number 2. Let's hit start and let's do number 2 because I haven't done it yet. Um, so here it says the perimeter of a square is given by square perim 4.0 times square edge. Exercise here is 4.1.2. You'll get different ones when you do yours, unless you like refresh, maybe skip to another exercise and come back or something, or try it and get it wrong and then have it reset. But this is what we have. The perimeter of a square is given by square perim equals 4.0 times square edge. Okay. And we got some steps, so follow them. Declare a double variable square edge and square perim. Okay. So down here, we declare the variables. How? Double, and then the name of the variable. So we want one called square edge. I'll copy paste it, comma. We have another one, square perim, semicolon on the end. Okay, we did it. Then it says, then read square edge from input. Okay, so there's two things here. Next thing is read square edge from input. So to read square edge from input, what you would do is you would write square edge equals, and to read it from input, it's going to be SCNR, the name of our scanner, dot, uh, next, capital D, double, parentheses, semicolon. Okay, so it's the same as reading an integer, except instead of capital INT, you write double with a capital D. So we read square edge from input. And the next thing is compute square perim using the formula. So now we need to basically use the formula that they gave us in the problem, which is here. They don't let us copy paste it, so I'll have to type it. But we want what it says, which is square perim equals 4.0 times square capital E edge. Like that. And that's it. So we should run this and it should just work unless we typoed something. And we got it. So there we go. Let's do number 3. Oh, they got a lot of math here. So here's what it says. Complete the code to output Q. Oh, to output Q equals, followed by the value of Q to 5 digits. Um, so in order to do this, we need to use printf, which is as it says here. Now, I'm going to go back to Eclipse momentarily to demonstrate something, but then we'll be right back. So let's just use this one again, where this is correct. Let me print it. So like we had a decimal here, right? I'll just pick a different number. Okay. Um, so we have a number and then we're printing it out, right? But this is printing out to a lot of decimal places. So if we want to control it, we can using printf. Okay. But the way you do it is with a placeholder. So in parentheses here, inside the printf, what you would have to do to print out some text is I could say like blah. And then if I want the number to go after the blah, I need a placeholder. And the placeholder for a double would be %f. But if I just do %f like this, and then after the quotes are closed, I do comma, and then what I want to print. So in this case, X, what you will see is that I got like 6 decimals of accuracy. Well, I want to control it. So the way you control the number of decimal places of accuracy is between the percent and the F, you put a dot and then how many places, decimal places you want. So like if I put .3 here and I run this again, you'll see I have 3 decimal places of accuracy, 222. If I wanted to put an 8 there, I would have 8 decimals of accuracy, right? So we want 5, I think, for the problem that we're doing, right? So we should do it like that. Now, another issue with printf is that if I do 2 of them side or one after the other, for example, you'll notice that they come on the same line. And that's because you don't get a new line with printf by default. So you're generally going to want to put a new line at the end of them. So after like the %.5f, you would do like a backslash in. And that backslash in, that is, whoa, the backslash in there, that's the new line. So if I did that on both of them, you'd see they come up on different lines now. So that's how we use printf. So coming back over here, it says we want to print it to, what's it say? Output Q equals followed by the value of Q to 5 digits after the decimal point. So what they want is this, but not blah, obviously. It says they want this Q equals. So that's what they want. Q equals. We do want 5 decimal places, so 0.5f is correct. And then the value of Q, so not X, Q. And then it says on the same line. Okay, so on the same line. So actually, I do not want that backslash in. It says output when V equals blah, blah, blah. Now, I'm going to do these on 2 separate lines of code like this, but they'll show up on the same line because I don't have the backslash in there. So the second thing we want to print is when V equals, and be careful. I don't know if you can tell this, but there's a space. There is a space. Let me go here. Make big, big. So notice that there's a space between the quote and the W, right? That's because they want there to be a space between the Q, which is being printed out on the previous line, and the word when. And it's supposed to be when V equals, and it says followed by the value of V to 3 digits. So we have to change the 5 to a 3. And we're printing V, so we have to change the variable to a V. And then it says end with a new line. So this one does need a backslash n on the end. So this should print it out correctly. And if you scroll up, by the way, you will find like descriptions of how to use printf, and they should explain the new line thing, like the backslash n is a new line, and so on up here. So let's see, did we get it? We did, right? We got it. So 3.8 and then Q equals 59 point whatever when V equals whatever. So there we go. So let's skip to the next one. This is scientific notation. Scientific notation is a math thing. I'm not going to talk about it a lot, but like how would I type this number as scientific notation in Java? Well, in scientific notation, you always write like you want 1 digit to the left of the decimal point, right? So this would be like 5.4. So you'd write 5.4. And then in scientific notation, it would be times 10 to the something, right? And in order to know what the something is, you'd have to figure out how many decimal places you moved the decimal point. So the decimal point would be here, and you move it 1, 2, 3, 4, 5, 6, 7, 8. So we would have to move the decimal place 8 places for scientific notation here. But the way you would type that in Java is 5.4, and then in place of the times 10 to the, you would write E. So it's just 5.4 E8. That's the correct way to do it. Okay, and then that means the same thing as 5.4 times 10 to the 8th. So it's the same for this. You would figure out how many decimal places you have to move it to get one number to the left of the decimal place. So 1, 2, 3, 4, 5, 6. So we would have 1.0. And then for the E part, we moved it 6 decimal places, but it wouldn't be 6 because remember, if you put a positive number, that's for big numbers that are more than one. Um, if you have a small fraction like this, we move the decimal place the other way, it would be a -6. So this is 1.0 times 10 to the -6. Okay, similar here. You would type this 6.23596 E. And then how many decimal places do we have to move this for scientific notation? 1, 2, only 2 places. So it would be like this. And we got it. Okay. So we have a problem here to do. This is acceleration of gravity, exercise 4.2.2. And we want to try to figure it out. Let's do this one, and then maybe we'll back up and look at the previous one. So let's read the instructions here. Compute the acceleration of gravity for a given distance from the Earth's center, dist center. So the Earth's center is dist center, or sorry, distance from Earth's center is dist center, assigning the result to accel gravity. The expression for the acceleration of gravity is blah. Okay, so what are we doing here? Well, they tell us compute the acceleration of gravity. Okay. They told us the variable name is accel gravity, which also I can see right here. That's the name, accel gravity. So we're calculating that. So accel gravity equals, and then what are we doing? Well, there's a formula for it. So we look at the formula for acceleration of gravity. It's up here, g times n divided by d squared. Now, you have to get the variables right. So comparing this formula to the variables that we have in Java, I can see that the top up here has capital G and capital M, and I can see that here we have capital G and capital M. So cool. So the top we can just do exactly the way it's written, G times M. Then we have divided by, more parentheses, divided by, more parentheses. And in the denominator here, it's d squared. And it says d is the distance in meters from the Earth's center. And then it says stored in variable dist center. So basically, here it's called d squared, but the variable name is dist center. So d squared is going to be dist center squared. And this is how I'll type dist center squared. Dist center times dist center. So this is my g times m divided by d squared. And I think that's it. And it was. Okay. So backing it up just to look at this one, just in case it's hard. Let's pick number 3 or something. Okay. How would you type this as a floating point literal? 7.583. And then how many places do we move it? Starting from the end, 1, 2, 3, 4, 5, 6. So that'd be 7.583 E6. Check it. Let's jump to the end. Let's do number 5. Initialize profit value with 9.3 times 10 to the 9th. Okay, so double profit value equals, we just need to type 9.3 times 10 to the 9th. So that would be 9.3 E9. They have the semicolon here. Okay, those seem pretty easy. Next section. So in the next section, we're talking about constants. We already have had the lecture about constants. It was in that same set of lecture slides we used last time, but from last week. So basically, you just put the word final in front of your variable declaration. So if you're declaring a double, it would be a final double, would make it a constant. If you were declaring an integer, it would be a final int, would make it a constant integer. So you put that word in front, makes it a constant. The names are going to be uppercase. They're not required to be uppercase. It's just what everybody does. Okay. So like here, the speed of sound and the seconds per hour, those are constant. So they made them uppercase. That's it. And you could use underscores as in place of spaces. As we're looking at this, actually, what I notice here is, at least in this web browser, they put a space here. And if that's not a web browser issue, this would not run. This code would not run like this. It would need to be speed of sound done with underscores like they did around here on the second one. I didn't notice that until just now. All right. Yeah, see, like here, speed of sound, they have the underscores, and then up here they don't for some reason. Weird. Just typo. All right. So which of the following are declarations of constants? This one's not, because it's not a constant. Like this is fine. This is an integer, but it's not a constant. Final int step size equals 14. That's the right way to do it. Total step height equals num steps times step size. What does it say? Declaration or uses of constant integer variable. Yeah, this would be fine, I guess. Step size equals step size plus 1. No, this would be changing the value of step size. And the point of a constant is that a constant does not change. So you can't change the size of it, which is what you'd be doing here. You'd be adding 1. So that's wrong. You'll get an error. Okie dokie. On this one, 4.3.1, what you got to do is you need the exercise, or you need the some statements from the left dragged over here to the right, and you can kind of put them in a couple different places. Now, what ones? Well, we have to read. So first thing says declare a constant variable cents per pound. So if you look here, there's actually 3 choices that declare cents per pound, right? Cents per pound, cents per pound, cents per pound. But only one of them is the correct way to make a constant in Java. So it's actually the top one, right? The word final makes it a constant. The third one, by the way, this is how you would do it in C. So it's just like it's correct, but only correct in a different programming language. So the top one's correct. So to do step 1, it's the top line, and we would do it here. They also make you put it and it indented the right amount. So this is the right amount. Cool. Read the shipping weight from the input and store the weight into ship weight pounds. So we're storing something in ship weight pounds. So we look for that. It's not the top 2, right? Those are constants. Shop cost cents, ship weight pounds. So read the shipping weight. So that's this last one. So you drag that over here, but under, right? Because we're doing these things in order. And then number 3, using the constants flat fee cents and cents per pound, assign ship cost cents with the cost of shipping a package. So our 2 choices here are just these 2 last ones, right? They're both trying to do the same thing. But if you look at the variables on the right, let's not think too hard about the calculation, but just look at the variable names. You'll see that the bottom one has flat fee cents and it's all capitals with the underscores. And here, the top one has flat fee cents and it's named the way a normal variable would be named. But just looking over here on the right, what are our variables called? Right? Flat fee cents. all caps. Flat fee cents, all caps. So this must be the right one. So this goes third, and it should also be indented the same as everything else. And that should be it. And it was. So it ran our code and everything was good. All right, math methods. So math methods are where the functions are that implement normal math stuff. So I'm trying to scroll down to a list. I'm hoping we can find one. I don't see a list. uh, Give me a list. Oh, okay, here. They were right here. So this is a partial list. There's a bunch of them. If you care, you can, if you just Google like Java math class and you scroll down to stuff that looks like documentation, like the one on oracle.com or the one on W3 School, we can click on that and we can get a list of, or kind of explanation. We can get like lists of all of these different types of functions, and then there's a more thorough reference here as well. And here's all of them, right? Like here's all the stuff in the math library, basically. Okay, back here. So the ones we care about in this section are SQRT, that's a square root, POW, which is how you do an exponent. So like POW x comma y is x to the y. ABS is absolute value, which just makes negative numbers positive. And of course, the square root, which we know what that does a square root. Now, any of these have to be typed in by math with a capital M dot and then the name. So it's like this, math dot SQRT, capital M. So if you do math square root 36, let me hang up on whoever's calling me. If you have math.sqrt 36, that's the square root of 36, which is just 6. If you do math sqrt 81, the square root of 81 is 9. Math pow to 8, that's 2 to the 8th power. At some point, these get a little bit tricky to calculate. You might try like a website like Wolfram Alpha if you just want to make sure you understand it. So over here, it'd be 2 to the 8th, like that is how you would type it in most calculators. It's 256. Another way to do it, by the way, is if you want to know what this is, you could just copy it. I mean, of course, we can just check a number and then see what it is, but you could also just put it into a Java program, right? And then we could just print it out. So you can check what it is, and it'll be 256, right? We could have just did a guess. Is this right? Math SQRT 28? No, right? So in order to do a power x to the y, you need two numbers, right? 2 to the 8th power. But for square root, you just take the square root of one number. So you would not put two numbers into a square root. So this is not valid. Similarly, when you're doing a power, you can't do a power of only one thing, right? It doesn't make sense. 8 to the what? Right? Math.pow 8 doesn't make sense. Could you do math.pow w comma x? If everything here was defined, like the w and the x were defined, that would be okay. And if you did this, what would you get? You'd have to kind of mentally do this. So if w is 3, then down here, you have w plus 1. So that would be 3 plus 1, which is 4. And then overall, this math.pow would be 4 to the power 2. So 4 to the power 2, 4 squared is 16. So this should be 16. So we want to, understand these basic math functions that you've seen before. Yeah. And then we want to think about how you could do stuff that's more complicated. So you can always do things in one line, but if we were trying to calculate this, x equals square root y squared plus z squared, we could do this in order, right? In pieces. The first thing you would do would be the y squared, then you could do the z squared, then you could do the square root of all of that stuff together. That's what they're trying to show you here. So if you were trying to calculate this in pieces, the first thing would be to calculate y squared. So if you look through here, which one of these is calculating y squared? And it looks like the third one, right? Math.pow y2. So that's y squared. After you calculate the y squared, you could calculate the z squared. So you look at the list down here and say which one of these is calculating z squared. And it's the second one, right? The top one's got an x, z squared. So now we have x squared, now we have y squared in temp 1, and we have z squared in temp 2. So temp 1 and temp 2 are the inside here. Then what you want to do is add them together and square root. So looking here, it looks like which one adds temp 1 and temp 2 and then does the square root. And it looks like the last one, right? Temp 1 plus temp 2, that's y squared, z squared. Add them. After you add them, square root. So it's that. Okay? Now, having said that, what they're talking about in the next thing here is that you could do this all in one line. So instead of separating this out into 3 lines like they suggest here, what we could actually do, rearrange a little bit, we could actually type this entire thing here in one line. So like, let's just say these have to have values, right? So I'm going to say double y equals, 2.0. I'm just putting in numbers so that the variables exist. Doesn't matter what they are. And then when we get to calculating the x, if we were trying to calculate the x using this formula, what I would do is I would say, well, overall, this is a square root, right? The last thing that happens is the square root. So I would say capital M math.sqrt parentheses. I'll just leave some blank space in there. In the square root, what do we have? Well, we have y squared. Now, the easiest way to do y squared would just be y times y like that. But if I want to use the power function instead of the y squared like that, I could calculate y squared with math.pow y and 2.0. The autocomplete tried to put an x in there, but that was wrong. So math.pow y 2.0, that is the y squared. Then we could do plus. So here we could do plus. And then we need z squared, which would be math.pow z squared. So that would be math.pow z 2.0. Okay. So that's one way to do it. And the point of this is just to understand that you could actually put math functions inside of math functions and it all works. Although if I were really doing it myself, what I would have done is I would have done math.sqrt, and for the y squared, I would have done y times y, and then for the z squared, I would have done z times z. So this is how I would have preferred to type it in rather than the top way here. Nevertheless, that's the point, is that you can put like powers and powers or whatever, and it's fine. Okay. Now, for figuring these out, you kind of would have to sit and think about them or just put them into Eclipse. So like you would work these out from the inside out. So like math.pow 2 comma 3, that's 2 to the third, which is 8, right? So like if you're working this out using your brain, which, why are you using that? Doesn't work, right? Um, if you were trying to work this out, like the way I would do it is I would say, okay, so the part that I'm highlighting, math.pow 2 comma 3, that's 2 to the third power. 2 cubed is 8. So I would replace that with 8. And then overall, now I have 2 to the 8th power. And, you can grab a calculator or go to Wolfram Alpha and do 2 to the 8th. And maybe we have it. I don't see, what do we have it? 2 to the 8th power would be 2 x to the y, 8. Enter. 256. So this would be 256. Okay. So coming back over to web browser, this would be 256.0. Okay. Now, the other thing you could do if you're too lazy to do that is you could copy these. You could go over to Eclipse, put them in. You have to make sure your variables are defined though. So make sure that you declare your variables. And then if we want to know what's in Z, just make sure you print out Z. 36. 36.0. And of course, you could still do this by hand because, for example, the part that I've highlighted here, math square root x, math square root x. X is 9, right, from the previous line. So the square root of 9 is 3. So this is 3 plus 3, which is 6. And then you have math pow 6 to the 2. So 6 squared, which is 36. My point was that if you're confused, you can just type it into your uh, compiler here. Again, you have to make sure that you declare everything as doubles and make sure you print out the right variable at the end. And we get 3. But you can work it out by hand. I mean, it's not that hard anyway. Math.absx, x is -9, absolute value of -9 is +9. And then you have the square root of 9, which is 3. So there we go. Good enough. So next exercise, I guess, 4.4.1. Let's pick, I didn't do number 2. Let's do number 2. Well, I guess I can go to any of them. Oh, they're not going to be difficult, looks like. So what does number 2 do? X equals math.abs 2.9. So what's the absolute value of 2.9? 2.9. Then it says this will output 1 decimal place. There's also a \n, which means a new line. So we're going to print 2.9. Okay. We're going to round to 1 decimal place, which it already is. And then there's a new line on the bottom. So we'll hit enter. And that's it. Okay, so these are really straightforward, I think. Let's check the next one. Math.pow 4.0, 2.0. So this one's doing 4 squared, 4 to the 2. 4 times 4 is 16, so x is 16. This will output to 1 decimal place. So we're going to print the 16 to 1 decimal place. And then there's a \n, which is a new line. So hit enter, check it. There we go. Let's do the last one. Oh, this one's the complicated one, right? So we have math.pow, but inside of the math.pow, we got math.sqrt. So you'll have to work from the inside out. Math.square root 4. Square root of 4 is 2. So then this is math.pow 4 to the 2. 4 to the 2 is 16. And then we're going to print it to one decimal place. So 16, enter. All right. So there we go. Now, this one here is the same as we did before, where we are just putting things in the right order. So they're clearly doing this in several lines here. So if you were going to calculate this entire thing, how would you do it? Well, like you could do the x2 minus x1 squared first. So look up here for where is x2 minus x1 squared. So the top one is x2 minus y2. That's not this. This one is y2 minus y1. That's actually this one over here. Down here, we have x1 minus y1 squared. That's nowhere. And the last one is x2 minus x1, comma 2. So that's x2 minus x1 squared because we're in a math pal. So this part is this one right here. So put that in. So that's the first part. After you do the first part, let's do the second part, the y squared. Sorry, y2 minus y1 squared. So we look for y2 minus y1. This one's wrong because it's x2, y2. This one's correct, y2, y1. So that's next. And then after you've got those both done, we need to add them together and square root. So it's got to be this one because this one adds them together and does a math dot square root. We probably could have put these in the opposite order and it probably would have been fine. All right, let's do at least one of these, two of these. Let's do number 2. Oh, okay. So this is a little bit sneaky, right? Not sneaky, but there's a lot going on here because we got the vertical lines are an absolute value. The square root is a square root. Where do we start? So, I mean, as long as you understand math, it'll be okay. We'll do answer because it says answer equals. So answer equals. And how do we type this? So the way I type it is I say the outside is an absolute value. That is capital M math dot ABS. Now I put the parentheses, and what I do is kind of just, let's move it over here a little bit, give myself some space inside to type. So math.abs. Inside of the ABS, I have a square root of W. So the square root of W is capital M math.sqrt parentheses W. That's the square root of W. After I have the square root of W, I need to divide by X. So that is just regular division though. So divide by X. And that's in the absolute value. So I have lots of space. Let's get rid of it. And I think this is it. So we just type them in. Think hard about how to do it right. Similar to the previous one, it's just another math formula to type. So I would say we have D equals. So we go D equals. I've got a big square root. Everything is inside the big square root. So math.sqrt. Again, I'll move that over a little bit, get it out of the way. What's inside the square root? Well, on top, there's b cubed. Easiest way to do that is b times b times b. That's the easiest way to do b cubed. But if you want to use mathpow, it'd be math.pow b comma 3. There's b cubed. Then we're dividing. So we divide. And it's c, but it's actually the absolute value of c. So we have to put math.abs c. So you just try to type that in carefully. Make sure, like the square root goes on everything. The B is cubed, but the C is not, right? So make sure everything is, make sure that what you type actually matches up to the expression. And there we go. All right. So last thing are the modulo. We're not going to do all of them, but we did already talk about these, okay? So we're not going to spend too much time now. We didn't talk about these particular problems, but we have to understand division with integers, and we have to understand with the remainder from what we learned last time. So like when you do 13 divided by 3, you say how many times does 3 go into 13? And the answer is 4. Not exactly 4, but it's 4 with the remainder of 1. So, but the division just gives you 4. Okay. How many times does 9 go into 4? It doesn't actually. Okay. I'm going to skip a couple. When you do 10 divided by 4, you'd get 2.5. And because they put the decimal here, it will do it as decimals. So 10 divided by 4 is actually 2.5. And it will be 2.5 because it will do the decimal calculation, not the integer calculation. Okay, this last one is exactly the same. And there we go. Division by 0 is undefined. You get infinity. Let's skip down to some of the modulo stuff, which is where I want to get. So the key here is to remember that it's the remainder, not like there's a quotient and a remainder. So like 2 goes into 50 evenly, right? 2 goes into 50 25 times with remainder 0. 2 goes into 51. Well, if you 2 will go into 51 25 times, but that'll give you 50, there'll be 1 left over. 3 goes into 5 one time, but 2 left over, right? So you have to understand this division with remainder concept in order to do these problems. 4 goes into 27. Well, 4 times 6 is 24. So 27 divided by 4 is 6. But that gets you to 24. Then there's 25, 26, 27, which is 3. So the remainder is 3, so on. Now, this one should be easy because we spent a long time in the previous lecture talking about this, that when you do modulo 10, what's going to happen is you're just going to get the last digit of that thing. So this will definitely be a 6. This does not make sense because 1 divided by 2 is going to give you 0 because these are integer calculations. You get 0, and then you try to do modulo 0. You can't divide by 0. So this is an error, and it'll say type error. On the other hand, 0 on the top is fine. 0 divided by 7 is 0 with remainder 0. Okay, let's go to something where we can actually do some calculations here. Let's start this. This does not, I don't see modulo here. Let's skip to like number 3. All right. X is 17. Y is X over 4. So 17 divided by 4. And then it prints them out. So it prints out X and then a space and then the Y. So it's going to print the X, which is 17, a space, and then the Y. What is Y? Well, 17 over 4. So that's going to be 4, right? It's going to be 4 because 4 goes into 17 4 times with the remainder 1. But we're not asking for the remainder here. It's just 4. Now, this one has a remainder, right? So the modulo is going to give you a remainder. So this one prints 5, right? Because it prints x, y. So it prints 5. And then we need to do 5 mod 2. So 2 goes into 5 2 times, but the remainder is 1. This one's just adding and multiplying. I'm not going to do it. This one is kind of thinking about what kind of remainders you could get. And so the key here is understanding that like when you divide, the remainder has to be less than the divisor. For example, like if you do, like, let's say 113 divided by 5, right? Now, that's going to be the what you'd have to say, well, actually, that's a bad number. I'll do this because I can do it in my head. How many times does 5 go into 103? It goes in 20 times, right? And then when you do the remainder, um, if you divide by 5, it'll go in 20 times and the remainder would be 3, right? But the point is that possible values for the remainder are 0, 1, 2, 3, and 4. You can't have a remainder of 5 when you're dividing by 5. Because if the remainder was 5 or more, then actually a whole nother 5 could have gone into the number, if that makes sense. So it always has to be that when you do on 5. And that's always going to be the case for any of them, right? Similarly, if you do like X, that's just a number, mod, if you did like 17, right, then the remainder could be 0, 1, 2, 3, dot, dot, dot. It would go up to 16, right? So it couldn't hit 17, but anything less would be okay. And that's what they're talking about here. Um, so this is kind of an annoying question, but if you wanted to get something between 5 and 10, what you could do is, well, let's think about these. If you did X mod 5, you would get something between 0 and 4, right? 0, 1, 2, 3, 4. So this one's wrong. If you did X mod 10, that would give you 0 up to 9, which is not 5 to 10. If you did X mod 11, you would get something between 0 and 10, which is not 5 to 10. If you do X mod 6, this would give you something between 0 and 5. But if you took 0 to 5 and added 5, right, and then instead of 0 to 5, you would have 5 to 10. So that's going to be correct. Um, so that's what's going on these. This one we specifically talked about in lecture last time, like quite a bit. If you wanted to get the tens digit, it's a two-step process. The first step would be to divide by 10, and the second thing would be to do mod 10. That's how you get a specific digit. Okay. If you had a 16-digit credit card, which gets the last 4 digits? Well, just like mod 10 gives you the last digit, mod bigger number would give you more digits. So it'll be this one. We didn't really do that, but in an example last time. All right, let's take a look at these, and then this is where we'll have to stop. Level 1, level 2, level 3. Let's do level 2. Level 3 looks like something we did in the other class, so let's do 2. Okay. 5.4, 4.5.2. Integer user val is read from input. They did that. Line 9. Assume user val is greater than 10,000. Okay. Assign 10,000's digit with user val's 10,000 digit. Oh, okay. So we have this variable called 10,000's digit equals, and Remember the steps for this, I guess I deleted them, trying to go back to where we were in the previous lecture. Do you think I can undo all the way to there? Yes. Um, so we saw how to do this. So when you want like the tens digit, you divide by 10 and then mod 10. If you want the hundreds digit, you divide by 100 and then do mod 10. If you want the thousands digit, you divide by 1,000 and then mod 10. So here, if we want the 10,000s digit, you would take the number, which is user val, you would divide it by 10,000, 10,000, and then after that, so we need this in parentheses, you would do modulo 10. And that will give you the 10,000s digit. And we got it. Right? And you can just see that we got the right answers in all these cases. Let's do the last one and then we'll really be done. Oh, okay. So this is kind of like the one that was like hours, minutes, seconds, but now we got to go pennies, nickels, quarters. So in order to do this, you basically have to think about, we need to know that, how many pennies everything is worth. So like there are 25 pennies in a quarter. We need to know that. We need to know that there are uh, 5 pennies in a nickel. We don't need to know dimes because they only put quarters, nickels, and pennies. Okay. So that's it. Quarters, nickels, and pennies. So this is very similar to what we did in the previous lab with minutes and seconds. So like the idea here is that if you're trying to convert like a large number of seconds into days, hours, minutes, seconds, it's a two-step process. You divide to find how many days there are, and then you do modulo to find how many seconds are left over. And then for hours, you divide by how many seconds there are in an hour to get hours, and then you do modulo to find out how many seconds are left over. And for minutes, you divide by seconds by how many seconds there are in a minute, and use modulo to find how many seconds are left over, right? So it's this two-step process of division and remainder. So the first thing you would do here, if they gave you 206 pennies, is you would figure out how many quarters that is. So to get the num quarters, what you would do is you would take the number of pennies, which is called total pennies, and you would divide it by how many pennies are there in a quarter? And the answer is there's 25, right? So there's 25 pennies in a quarter. After you do that, so that's going to calculate the 8. After you do that, you need to figure out how many pennies are left over. So to get the leftover pennies, you're going to have to do total pennies equals total pennies modulo 25, right? So these go together. So you calculate the quarters and then how many pennies are left over. And it's divided by 25 and then modulo 25. And then it's the same for nickels. So to get the num nickels, it's going to be the total pennies divided by how many pennies are there in a nickel? And the answer is 5. After you do that, you need to figure out how many pennies are left over. Now, I could do it this way, total pennies equals total pennies modulo 5, like that. And this is all fine. This is going to calculate the number of quarters and the number of nickels and the number of pennies. But down here, when they're printing it out, I see they've got another variable for pennies called num pennies, right? There was total pennies, but then there was also num pennies. So just to make sure the right number gets printed out at the end, I'm going to change this total here to num. We'll put it in that variable. And that's it. Okay. So watch the previous lecture if you want more explanation for how to do this. But basically, it's kind of these groups of two where you do division and modulo. All right. So we did it. And that is it for today. So I'm going to stop this recording here and post it for you guys. See you guys next time.